Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tam from Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid-state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid-state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series in applied electronics. We have been going through a series of lectures on the phenomena of interference. This comes under the chapter on optics obviously, and in today's lecture, that is the lecture number 14, the contents will be as follows. We will have first a brief review of theories of light, change of phase due to reflection, colors of thin films, the continuation of what we have been seeing in the previous lecture, conditions for constructive and destructive interferences, interference in thin films, condition for bright and dark fringes. That is a theory of colors of thin films. Now, let us see the brief review of the theories of light. Now, the light ray which is coming from a source, according to Newton, it travels in the form of straight lines, and he advocated what is called corpuscular theory of light. What do you mean by corpuscular theory of light? A light ray consists of minute corpuscles. Corpuscles means packets of energy. So, the light ray, it consists of packets of energy, and it comes in straight lines. That is what Newton thought. This is the Newton's theory of light. But on the contrary, there were a few phenomena such as the one that we are discussing now, namely interference, then diffraction, about which you will see in the lectures to come, and polarization. Now, these new phenomena which are observed a century back, now these phenomena can be explained only on the basis of what is called wave theory of light. What do you mean by wave theory? That is, light travels in the form of waves, not in the form of straight lines as was proposed by Isaac Newton. So, Newton's theory is correct in some sense, but you have the wave theory of light proposed by Huygens in 1680, and there is enough experimental evidence to show that actually light travels in the form of waves. As I told you, the phenomenon of interference can be explained only by assuming light to be traveling in the form of waves. The corpuscular theory, or the so called rectilinear propagation of light, that is, light travels in the form of a line, rectilinear propagation, was proposed by Isaac Newton, that cannot be applied, or if you apply, you cannot apply in the phenomenon of interference. So, interference phenomenon is something like the interference that you observe on the surface of water waves. By putting two stones simultaneously, you generate waves and the waves interfere, right. So, the interference that could be seen by naked eye in the mechanical waves which are developed on the surface of water, those waves can be, the phenomenon of interference that you observe can be explained only by assuming light to be, water to be traveling in the form of waves, you have got a wave traveling on the surface of water. Similarly, the light wave also coming from any source, it reaches your eyes or travels in the form of waves. That is proposed by Huygens. Wavelets, each point on the wave front acts like a source for the next wave front and so on. This is the wave theory of light proposed by Huygens, that should be taken into account, otherwise you cannot explain these new phenomena which I have been talking about. Again, you have what is called thin film interference pattern. What do you mean by thin film or colors of thin films? You see, when you walk along the road, as I told you in the last lecture, you see water to be splashed or water on the road, and if you have got some kind of petrol vapor or petrol or some oil which has been spilled over water. Now, the water that you have got, muddy water, it appears to be colored, and this is called you have a thin film, right, thin film of petrol or oil, that gives rise to colored pattern that is due to the phenomenon of interference. And I again tell you that Thomas Young's double slit experiment showed conclusively what Huygens said is correct. Whatever Huygens proposed was observed in the Young's double slit experiment. So, Young's double slit experiment conclusively proves that light should travel in the form of waves. Okay. That what about are you considering light to be made up of waves always? It is not, again not correct. Light coming from a source, again if you place a metal plate or you go out of the room and you place a metal plate made up of cesium. Cesium, what is the melting point of cesium? In the whole of periodic table, the melting point of cesium is the lowest, namely 25 degrees centigrade. If you place a metal plate made up of cesium, and because you have got sunlight falling on that, then the electrons will be coming out of the metal plate. Now, these electrons which are coming by a photo process, the light which is incident, as I show here, light which is incident from the sun or any light source, it is able to bring out electrons from, this is a metal, right, a piece of metal. The electrons which are residing here, the so called free electrons, will be coming out of the metal plate, and these electrons which are ejected by a photo process by light, it is called a photoelectric effect. And of course, all of you should be knowing by now that Einstein was given the Nobel Prize for explaining this phenomenon of photoelectric effect, wherein you find that photo means light, light which is incident on a metal plate will eject electrons, and so this phenomenon is called the photoelectric effect. And here what you do? Now, if you want to explain the photoelectric effect, you have to consider the light beam or light waves to be made up of what? Photons. All of you should be knowing the word photon. Photon is a quantum of energy, right. Light is not simply, you should not always consider light to be made up of waves. It consists of photons, packets of energy, okay, and you have got light to be considered as made up of waves and also as made up of photons, right. Light has got dual nature. What is dual nature means? It depends upon whether you are placing a metal plate. If you are placing a metal plate, light which is incident on that will eject electrons. In that case, the ejection of electrons can be explained only by assuming the incident light to be made up of photons. That is the explanation that was given by Einstein, which made him to win the Nobel Prize. So, the photoelectric effect can be explained only by assuming light to be made up of photons, right. So, light is made up of particles called photons. On the other hand, if you want to explain, so light energy is quantized. Einstein gave the theory in 1905. Photon is a quantum or packet of energy that when incident on a metal plate will expel or eject electrons. This is so called photoelectric effect, and this is the proof of particle nature. The light wave is made up of photons, right, or light energy is made up of photons. On the other hand, you have got the Thomas Young's double slit interference experiment showed an interference pattern, and you could measure the wavelength of light and so on, and you see them two waves interfering, right. Now, these waves are light waves, or you can assume disturbances caused at 2 points. So, you talk about Young's double slit experiment. You got one slit here, the light coming from the two slits, you got slit here, light coming from the two slits, they will, you have the pattern, one you have generation of waves here, generation of waves here, and these two waves interfere, right. And the interference, what you have to do? You have to find out the resultant. When two waves meet each other or interfere with each other, then what is the resultant wave, whether they add one with the other, that is will there be a constructive interference or will there be a destructive interference. All of you know by now, in the very early lectures I told you that when a crust is meeting a crust or a trough is meeting a trough, there will be constructive interference. Then you know the amplitude gets doubled, whereas a crust meets a trough, that will lead to destructive interference. So, here you have constructive interference or destructive interference. So, you have a pattern, right. You have got you see here a bright fringe, that is due to constructive interference. You have got a dark fringe, that is due to the destructive interference, because A minus A will be equal to 0. One wave will be like this, it is going up, the other wave that is coming from the second source, it is having a crust, the other is this has got a crust, this is a crust, this is a trough here, right. So, it is plus A from the equilibrium position, this is plus A, the amplitude here it is minus A, plus A and minus A will be equal to 0. That is what is happening here in this region, right. The intensity drops to 0 here, whereas the intensity or the displacement is large, giving rise to a constructive interference or a bright band or a bright fringe, whereas here the intensity is 0. So, it gives rise to no light, a dark region or a dark band. Again the intensity I max, I is the intensity, that is maximum intensity here, giving rise to bright band, again a maximum intensity bright band, and wherever the intensity becomes 0, you have the dark bands. This is what you get from Young's double slit experiment, wherein you make light to pass through two slits. You see a slit here, right. This is Young's double slit experiment. So, Young was able to show when light is getting propagated or a coherent laser light is there, and when it is going through two slits, you see a slit here, the waves are spreading through the slit S1, the light wave is coming here, and from the slit S2 light wave is coming here. When the two waves interfere, then depending upon whether the amplitude of the wave coming from the first one, whether the amplitude is plus A, for the second also it is plus A plus A will be 2 A, that is a so called constructive interference, that a crust is meeting a crust, the trough is meeting a trough. In both cases there will be a constructive interference. You see here a crust is meeting a crust. You see from the first source you have the wavelet here, from the second source you have got the spreading of the waves, you have got you see the point here, this is this wavelet and this wave front, both of them are overlapping. The crust is meeting a crust, means there will be a constructive interference. Here there is destructive interference, the crust is meeting the trough of the second wave, crust from the first wave is meeting a trough from the second wave, thereby the intensity, as I told you, will be equal to 0, giving rise to a destructive interference or a dark band. So, similarly, so what is shown here, the intensity distribution is, what do you see here, a bright band, right. You have bright here corresponding to this, you got a bright band, then you got a dark band and so on. So, similar to what I showed here, a bright band, a dark band, bright band and dark band. So, you have got in all the experiments which you are going to see, whether it is air wedge I will be talking about, the theory of the air wedge or the experiments that we will be doing with the air wedge, and or Newton's rings, the rings observed by Newton, we will be studying about Newton's rings. Now, these experimental observations can be explained only on the basis of wave theory, and again based on the concepts which we are developing now, whatever ideas we are developing, namely the constructive interference, destructive interference. So, in Newton's rings also you will have bright rings and dark rings and so on. Similarly, in the air wedge also you will have bright band, dark band, bright band and so on. So, these occurrence of the bands or the bright and dark rings that you are going to see as observed by Newton. Now, these experimental observations can be explained only by these ideas which we have developed or understood by now. So, you see again the light coming from S1, that is the source S1 here, a beautiful animation, S2 is here. So, the light coming from S1 and S2, then you get the wave pattern, and the wave pattern will be, you see the spreading of waves, they will obviously they will be interfering, and because the interference, either you get a crust meeting a crust or a trough meeting a trough, or the other way around, crust meeting a trough, that leads to destructive interference. This is again a beautiful animation to understand the phenomenon of interference. Now, does this make any sense? What do you mean by saying that this makes any sense? Now, here it has been written, use both exists when leaving the parking structure. What do you mean by both? Both is, now let me ask a question, what do you think about light? How light is getting propagated? I see a light source here, my eyes are here, the light is coming to my eyes. Now, how light is getting propagated? Sound is propagated, when I am here, you are there, you are able to hear what I am telling, the sound is propagated through air. Similarly, you have to see the propagation of light. Now, how does light get propagated? Or in other words, I will ask the question whether light consists of rays of light, whether it is made up of waves or it is made up of photons. Newton said light consists of rays. Huygens said that light is made up of waves. Einstein said light consists of photons. It is Max Planck who proposed the quantum theory. He said that according to Planck's quantum theory, light consists of packets of energy called photons, but that was made use of by Einstein to explain the photoelectric effect. Now, you got three choices. Now, you have to make up your mind whether light is made up of rays as proposed by Newton, or Huygens said that light travels in the form of waves. Then Max Planck and Einstein, according to them, light consists of photons. Which one of the three is correct? Now, the important point to be made to be understood the following: light has dual nature. Light is acting or behaving like waves at certain times, and it is behaving like particles or made up of photons at other times. At this point, someone asked a question: on Mondays, Wednesdays, Fridays, light is behaving as waves; on Tuesdays, Thursdays and Sundays, it will be behaving like particles. Whether science is or physics is so very uncertain. Today it will be acting like a wave, tomorrow it will be acting like a particle. So, it has got dual nature. Is this right? It is not right. The correct thing is it is for you to see the wave aspect or the particle aspect. You have the same light source. If you are placing a cesium plate, electrons will be coming. So, the photoelectric effect will be there. For explaining this, you have to consider this light beam to be made up of packets of energy, photons, particles of energy, right. Light is made up of particles of energy called photons. On the other hand, if I place a air wedge, which I will be showing just now, or the colors of thin films that saw earlier, or the interference pattern that you get now, the interference pattern that you observe. Now, these things are the Newton's rings and very many other things. Okay, you replace the cesium plate, by a biprism, right, by a prism, or you have a glass plate and a lens as was had by Newton, and you could see them rings, beautiful rings, wherein bright rings and dark rings, there are lines, right. But instead of that, I will be showing Newton's rings will be bright and dark, and the bright and dark bands that you obtain. Essentially what I am trying to tell is, if you place the metal plate, cesium plate, you get the photons striking and the electrons are coming out. This phenomenon can be explained only by assuming light to be made up of particles called quanta or photons. On the other hand, if you replace the metal plate by a biprism or a air wedge or a lens and a plate, then you observe the Newton's rings. Now, if you do that, the observation of Newton's rings or the bright and dark bands that you obtain can be explained only by assuming light to be made up of waves. It is for you to do, or you are going to place a metal plate, or you are going to place a biprism, or you are going to place a plate and a glass plate, as was done by Newton. So, it depends upon what essentially we are discussing about interaction of same radiation, interaction of radiation with matter. Matter means, if you are placing a metal plate, electrons will be coming out. If you are placing a biprism, then you get bright and dark bands. It is for you, if you are placing a biprism, you will be getting interference pattern that can be explained only by assuming light to be made up of waves. On the other hand, if you place a metal plate, you will be getting electrons, that can be again only be explained by making the assumption that light is made up of photons. So, light acts like particles containing photons, and it ejects electrons. So, it is for you whether you, if you are placing a metal plate, you have to treat the light as though it is made up of photons. Light consists of photons, that then only you can explain the photoelectric effect. On the other hand, in the case of Newton's rings or the Young's double slit experiment, where you get higher intensity, lower intensity as shown in this slide, then you should treat light as if it is made up of waves. So, you should not be confused. It is for you whether you are placing a metal plate or you are placing a air wedge, depending upon what you are doing, you will be either seeing the particle aspect of the same radiation. You have here, you know, the light beam is made up of photons, right. This is what you get the electrons, the photoelectric effect. Light is should be considered as made up of photons. On the other hand, when you have this kind of thing, two light sources giving rise to bright and dark bands, in this experiment the same, one of the same light sources there, you have to treat light as if it is made up of waves. Therefore, you end up by saying light has dual nature. This is a very important thing that you young people should understand. Light has dual nature, it has got dual nature. It will not be acting like particles on Monday, Tuesday it will be acting like waves and so on. It is not true. It depends upon whether you are trying to observe this pattern and you are doing an experiment of this kind. Then if you do an experiment of this kind, light should be treated as waves in order to explain the occurrence of or the formation of bright and dark bands. On the other hand, if you want to explain the the phenomenon of photoelectric effect, wherein electrons are coming out of the metal plate, then you have to treat the light beam, the same light beam, as if it is made up of photons, as was done by Einstein. The original idea was given by Max Planck in 1901, but it was used by Einstein. He was the first person to make use of Max Planck's quantum theory to explain the photoelectric effect. If you assume light to be made up of waves, if you use the electromagnetic wave theory, then this phenomenon of photoelectric effect could not be explained. People tried to understand the photoelectric phenomenon and making or thinking that the light to be made up of waves, but one cannot explain. This is instantaneous phenomenon that cannot be explained by assuming light to be made up of waves. One has to definitely bring in the quantum aspects and quantum theory of radiation. Light is made up of photons, the quantum theory of radiation. So, light radiation consists of photons, then only you can explain the photoelectric effect. So, finally, what the important point is, you have the light is having dual nature. It has got both particle aspect as well as the wave aspect. This is the important thing that should be remembered by the younger people like you. Let me now summarize some of the important points. There will be a phase change of pi when light is incident from a rarer medium on a denser medium. When it is reflected, there will be a phase change of pi. A phase difference of 2 pi will correspond to a path difference of lambda, and finally, light should be treated as if it has got dual nature. Now, the questions are, when a light wave encounters a denser medium and gets reflected, will it undergo a phase difference? What do you understand from the words colors of thin films? With this, we come to the end of lecture number 14, and in the lectures to come we will see the phenomenon of what you see in air wedge, Newton's rings and so on, about which I mentioned in this lecture. Thank you.